Hi, good morning or good afternoon or good evening. It's already 8:49 here. So again, I apologize for getting back to you so late. I just got home. Let's go with this. Let's go through this a little bit more. Let's go back. I'm going to go back to trig and try to follow, and hopefully you could follow along from there. Okay. This isn't a magical lesson. This is difficult. Okay, so it took me a while to get this, and it took a lot of studying. So hang in there. It's not easy to understand. So just do the best you can, and just watch other videos if I'm not clear. But I want to do the best I can to explain. Okay. All right. So let me get the whiteboard out here. And when I do this here, okay, let me see here, it's smaller. The less of me, the better. Okay, and then move that up here. Okay, so when you're in geometry or I think integrated math, I don't know, you learned about these two special right triangles, 45, 45, 90-degree triangles, and 30, 60, 90-degree triangles. These are called special right triangles. All right. And they're special because there is a pattern to them. Okay. So, let's just say this is a 45, 45, 90. Sorry, I can't draw. I'm just trying to, yeah, I'm trying to get used to this whole, what you call it, Wacom board. And so these are both equal to each other. These two legs are equal to each other in a 45, 45, 90-degree triangle. And so let's say this is the leg and this is the leg. The hypotenuse, you could do the Pythagorean theorem if you like, but just as a shortcut, if you just multiply the leg times the square root of 2, that equals the hypotenuse. And that, again, that's going to be important for the unit circle. All right? So, and when you get to the 30, 60, 90 triangle, okay, all right, so you get this is 30, this is 60, and this is the 90-degree triangle here, or this is 90 degrees. All right, this is the shortest leg, okay, and the shortest leg is half of the hypotenuse. In other words, if you multiply the short leg by 2, that'll equal the hypotenuse. So this is 2, that means that this is 4, okay? If the short leg is 6, that means that the hypotenuse is 12. So now you might be asking, what about this side? Well, if you multiply the short leg times the square root of 3, that's the long leg. So it'll be root 2 root 3. And if the short leg is 6, it'll be 6 root 3. So those are quick shortcuts or shorter ways of solving for 30, 60, 90 triangles. Okay, now let's go to the unit circle. Okay, so I'm going to erase this. All right, and you might want to look up 45, 45, 90-degree triangles and 30, 60, 90. These are, again, shortcuts. Instead of doing the whole Pythagorean theorem, you just know these right away, and you could solve for the leg or the hypotenuse right away. All right, now let's go to the unit circle. Now, it's called the unit circle because the radius is 1. So if I have, draw this here. If I have an x-axis and a y-axis and an x-axis, and I draw, as I did yesterday, I should do a hollow circle this time. So from here, all right, so let's say this was the unit circle. So why is it called a unit circle? It's because the radius is 1 unit. This is 1 right here, okay? This is also from this is from here, from the center to the edge of the circle is always going to be 1, okay? And this is going to be 1 as well, okay? So now this is a 1 unit circle here, okay? So now let's say this. Let's say I drew a triangle right here, and this was 30 degrees, all right? And remember what I said about 30, 60, 90 triangles, right? This is a 90 degrees, so this is 60 degrees right here. So if this is 1 unit, if the hypotenuse of this is 1 unit, that's the radius also. Okay, if this is 1 unit right here, what would the short leg be equal to? So the short leg, remember, you have to multiply this by 2 to get to the unit right here. So this is going to be 1/2. Okay, and then this portion right here is, remember, √3 times whatever the short leg is. Okay, so this portion right here is going to be 1/2 times √3, which is also equal to √3 over 2. Okay, so this portion right here is √3 over 2. So now we ask, okay, so how do I get the cosine of 30 degrees? All right, cosine of 30 degrees. So if I did the cosine of 30 degrees right here, remember the cosine is equal to the adjacent over the hypotenuse. So the adjacent right here is √3 over 2. And the hypotenuse is over 1. And anything divided by 1 is itself, so the cosine, that's why the cosine of 30 degrees is equal to √3 over 2. Okay, hopefully that's helped. That's kind of, I hope you're figuring that out. Now let's look at the sine of 30 degrees. Okay, the sine, remember, is right here is the opposite, which is 1/2 over the hypotenuse, which is 1. So the sine of 30 degrees is equal to 1/2. All right, so hopefully that's helping out a little bit. All right, so hopefully that's making a little bit more sense. All right, now let's do this portion right here. Let's go this portion, and let's say this angle right here, let me change colors. Let's say this angle right here is 45 degrees. If that's 45 degrees, that means that I could draw a line here, draw this circle right here. That means that this angle is also 45 degrees, and this is 90, which makes it a 45, 45, 90 degree triangle. Okay, so remember that we have the unit right here. This is 1, and remember when a 45, 45, 90 degree triangle, okay, the leg times the square root of 2 is equal to the hypotenuse. All right, and we know that the hypotenuse is equal to 1. So when you divide by the square root of 2 to both sides, you cross that out. The leg is equal to 1 over √2. Now again, or not again, but remember that you cannot have a root on the bottom because it's an irrational number. So what we're going to do is we're going to multiply the √2 over 2. And that equals √2 over √4. And √4 is equal to 2, so it'll be √2 over 2. So now we ask, okay, so what is the cosine of 45 degrees here? Well, the cosine right here is, remember, the x value is the adjacent over the hypotenuse. So that's equal to what? √2 over 2 over 1, right? Because this is the hypotenuse, this is the adjacent. Anything over 1, cosine of 45 degrees is equal to √2 over 2. All right, I'm hoping that you're kind of getting this. Now the sine, remember the sine of 45 degrees, remember cosine and sine are the same here because this is the cosine, this is the sine, correct? This is the opposite. And these two are the same, so the cosine of 45 degrees is also √2 over 2. All right? So that's the unit circle part. Now let's go to the sine and cosine waves here. So I'm going to clear this. Okay, again, you can pause this. You try to understand this portion right here. So let's pause this. Oh, so let's move on. Again, you can always pause it. All right, so now let's graph on a xy coordinate let's say the cosine of x. All right, y is equal to the cosine of x. So if I have something like this, all right, I want to make a table of values, right? The table of values would be if I make this, let's say, cosine or cosine of 30 degrees, that equals √3 over 2. The cosine of 45 degrees is equal to root 2 over 2. Okay, the cosine of 60 degrees, remember 60 degrees is up here, so that would be the 1/2, right? And then the cosine of 90 degrees would be at 0, all right? So now, let's look at these right here. Now, let's say this is 30 degrees. This is another 15, that's 45 degrees here. Let's say this is 60, and then right here would be 90. All right. So then we'll start at 0. So the cosine of 0 degrees is equal to, remember it was 1, right? And remember what we said, that was our amplitude. That's right here. Now, if you calculate root 3 over 2, the square root of 3, I believe, is, let me check on your calculator. So if you do the square root of 3 square root, that is 1.73, and you divide that by 2, that's approximately, so this is 0.86 on your calculator, or let's say 87. Okay, if you go to root divided by 2, 1.41, and then this will be about 0.71. Okay, and then 1/2 is 0.5, right? And that's 0. All right, so if you notice that as we go along for each step, it's going down as we speak, and then it hits the 0 at 90. So it's at half here. So this is the halfway point, so about like halfway here. 7, 1, and then 8, 7. So you notice that the graph is doing something like this. Okay, and at -1, it's gonna hit and it's gonna go down this way, and it will do this as we go along. All right, it'll just do something like this. All right, now let's go to the graph here. Okay, all right, let's clear this here. Let's see here. All right, let me go back and let's go to this right here. Okay, hopefully you see the graph. Now you're at number 8. All right, at number 8, the amplitude is 1 because the graph hits the 1, right? And let's say that, I know that the numbers are kind of not clear, actually not really not clear, but let's say that the x-axis is -2 pi, pi, 0, pi, 2 pi, so it's going by increments of pi, all right? So let's go back to the drawing board here. Here, let's see here. There you go. So let's go back to the drawing board here. And we have a graph right here where it starts at a -1, right? And then it goes up this way and down this way, up this way. And where is it? It goes up this way and down this way. So we know that the amplitude is -1. Why? Because remember the cosine was here. So since the graph is on this end, is on the negative end, we know that the amplitude is 1, and we know it's cosine, right? Because if you look at the unit circle, right? Okay, and if it's negative cosine, all right, let's see, it's our -1 cosine. We know that it just switches from here to here. All right, so remember when I did the cosine of 0 degrees, right? Cosine is 1 right here. Well, if I go -1, it's right here. So this is a -1 right here. Okay, so that's why it's negative right here. We know it's cosine again because it starts at a 1. All right. So remember, I'm looking at the 0 for the x, and I'm looking at where it starts from, okay? And if it starts at 1 or -1, it's cosine. If it starts at the origin, it's sine, all right? Now I have to see the period. What's the period of this whole thing, okay? Let me get to this here. Let me see what the period is. It's from, height is at pi, and height is at pi, 2 pi. Let's see here. So the height's at, so it starts at 2 pi. This is a period, 2 pi, and it goes all the way to 2 pi. All right, so it starts here. This is one full length right here. Okay, and so when you get that, right, it should be, the period is it 4 pi? Yeah, the period is from here, pi, 2 pi, 3 pi, 4 pi. So the pi is 4 pi here. So that's the period. Give me a second here. All right, I'm going to stop for now, and then I'll get back to you. Okay, so let me stop this recording, and then I'm going to start another one in a little bit.